This lesson will be on 2-3, solving one-step equations with multiplication or division. When given an equation where we have multiplication, for example 1, we have 5 times n equals 25. To undo this multiplication between the 5 and the n, we'll have to use our opposite operation of division. So we'll divide both sides of our equation by 5. On the left side, we have 5 divided by 5, which is 1, so those 5's cross off, and we're left with n. On the right side, we get our answer of 25 divided by 5, which is 5. Here's example 2. We have a negative 3 times n equals a negative 12. Remember that this is a negative 3 times n. So in order to undo this multiplication between the negative 3 and the n, we'll be using division. We'll be dividing both sides by a negative 3. On the left side, we have a negative 3 divided by a negative 3. Because we divided by negative 3, our negative signs cross off. A negative divided by a negative is a positive. And then we have 3 divided by 3, which is 1, so those 3's as well cross off, and we're left with n. We've isolated n. On the right side, we have a negative divided by a negative, which crosses off. That's a positive. 12 divided by 3, which is 4. In example 3, we have t divided by 7 equals a negative 5. Because we have division right here, t divided by 7, we'll undo that division by multiplying both sides of our equation by 7. 7, on our left side, we have 7t divided by 7. 7 divided by 7 is 1, so they'll cross off, and we have just t left over. On the right side, we have a negative 5 times 7, which is negative 35. Here's example number 4. We have t divided by 36 equals 4 over 9. Now again, here we have division, t divided by 36. So to undo this division, we'll be multiplying both sides of our equation by 36. So we have 36. Here we'll multiply by 36 over 1. On the left side, we have 36t divided by 36. Well, 36 divided by 36 is 1, so those 36's cross off, and we're left with t. On the right side, we have 4 over 9 times 36 over 1. Remember that we should always be reducing any top number with any bottom number. So 9 and 36 reduce. 9 goes into itself once, and 9 goes into 36 4 times. So we're left with 4 times 4 on our right side, which is 16. In example 5, we're given 1/4 n equals 4. In this example, we're given a fraction of 1/4 times n. So we're given a fraction times n. In order to undo this multiplication, we'll multiply by the reciprocal of 4 over 1 on both sides. If you notice, when we multiply fractions, we can always reduce. So the top 4 here on the left side crosses off with the bottom 4 because it's 4 divided by 4. Those both cross off. They give us 1, and we're just left with n. That's why we multiply by the reciprocal when given a fraction. On the right side, we're left with 4 over 1 times 4 over 1, or 4 times 4, which is 16. Example number 6 is the same type of problem. We have 1/2 n equals 5. In order to undo the multiplication between the fraction and the n, we'll multiply both sides by its reciprocal of 2 over 1. We can turn the 5 into a fraction as well if you'd like. On the left side, we have 2 over 2, which crosses off, and we're left with n. On the right side, we have 5 over 1 times 2 over 1, or 5 times 2, which is 10. In example 7, we're given 25 divided by n equals 5. I know most of you can do this in your head and understand that 25 divided by n is 5. However, you have to understand the process of isolating n when it's on the bottom of a fraction. In order to isolate this n so that it's not on the bottom of a fraction, you'll have to move the n to the other side. So we'll multiply both sides by n first. That way it crosses off of the left side and moves to the right side. Now we're left with 25 equals 5n. And now we can isolate n by dividing by 5. So n equals 5. In example 8, we're given the same type of problem, except you won't be able to figure this one out as easily. N is on the bottom of a fraction, so what we'll have to do is we'll have to move this to the right side of the equation. We'll start by multiplying both sides by n. On the left side, an n on the top crosses off with an n on the bottom, and we're left with 49. On the right side, we're left with 5n. Now in order to isolate n, we can divide by 5. N equals 49 over 5. Here are our last two examples. In example 9, we're given 3/5 times g equals 6. Remember that in order to isolate g when multiplied by a fraction, we'll multiply by the reciprocal. So both sides will be multiplied by 5 over 3. It may be helpful to make the 6 a 6 over 1. On the left side, a 3 on the top crosses off with a 3 on the bottom. A 5 on the top crosses off with a 5 on the bottom. So we have 1g, or g. On the right side, we'll be multiplying 6 over 1 times 5 over 3. But remember that you can always reduce before you multiply. This 6 and the 3 can be reduced together. 3 goes into itself once, and 3 goes into 6 twice. So we're left with 2 over 1 times 5 over 1, or 2 times 5, which is 10. And our last example, negative g over 24 equals 5 over 12. In order to isolate our g, and right now we'll be isolating a negative g, we'll be multiplying both sides by 24.
Nice.
On the left side, we have 24 divided by 24, so that crosses off, and we're left with just a negative g. On the right side, we have 5 over 12 times 24 over 1. Remember that we can reduce first, so our 12 and our 24 here can be reduced together. 12 goes into itself once, 12 goes into 24 twice. So we're left with 5 times 2, which is 10. However, we cannot leave our answer like this. We always have to solve for a positive variable. So in order to solve for a positive variable, we're going to undo this multiplication between a negative 1 and g by dividing by negative 1 on both sides. Negative 1 divided by negative 1 will cross off, and we'll be left with g equals 10 divided by negative 1, which is a negative 10.